Today we are in this video is going to start the higher order derivatives, or to study about the Leibniz theorems, how to use it. And simply we take the one questions which is related to the log. Question is here, and let's start. Let's solve it. Start from the solution. The focusing log y is equal to tan inverse x. This is the questions, and we have to show that 1 plus x square yn plus 2 plus 2nx plus 2x minus 1 yn plus 1 times plus n square n square plus n yn is equal to 0 to prove it. First of all, we have to question this much. Log y is equal to tan inverse. So first of all, we have to derivative it. So differentiating with respect to x, we get d log y dyx equal to d tan inverse minus x by dx. Simply we have the formula of derivative of the log y is 1 by y dot derivative of dy by dx is given by the y1 is equal to, and we have also simply formula derivative of the tan inverse is 1 by 1 plus x square, and arrange it 1 plus x square y1 is equal to 1, so that we have to easy to differentiate it again. So differentiating n times differentiating second time with respect to x. Because why should we differentiating it second times? Because so we have to prove that n plus 2 times, it means 2 times the function of x is derivative by 2 times, so that we have to derivative it 2 times, and this term is in the form of the product form, so we use the product form derivatives formulas, that simply we write it as it is 1 plus x square, and derivative of y1 is y2 plus, and derivative of 1 plus x square is 2x, and simply we write y1 is equal to derivative of y is y1. This is enough. Arrange it. Common y1 2x minus 1 is equal to 0. Now we have to the further we are solve the 1 plus x square by yn plus 2 nearly, so that we have using the Leibniz theorem to finish out this question. Differentiating n times with respect to x by using Leibniz theorem. It was so simple. 1 plus x square retain this term. First we have to complete this term, then after completing this term, then we have to go further this term. First of all, we check out these terms using the Leibniz theorems. 1 plus x square y2, this is in the form of the product form, and we using the n times derivatives. It means many times 2 3 4 5 6 times, where if we put n is equal to 1 2 3 4 5 so on. So 1 plus x square derivatives yn plus 2 times n plus 2 times plus and again this term 1 plus x square is derivative, then it could be the 2x. Simply we have to the nc1 formula we have to write first, then derivative 1 plus x square, then it could be the 2x, and yn plus 2, it means further increasing the derivative is also decreased by minus 1, so we should write yn after subtracting minus 1, it could be the n plus 1 plus n c further 1 times after 1 time, then it could be the 2 here, and derivative of the 2x, then it could be the 2, then subtracting yn plus 1 minus 1, then it could be the yn. After isolating the 2's values, then we go further second term, that is y1 2x minus 1, then it could be the first it could be written as it is 2x minus 1 and y1, so that n plus 1 plus derivative the 2x minus 1, then it could be the simply 2, then n c1 we have the formula 2, then in the yn is subtracted, yn plus 1 subtracted by minus 1, it could be the yn, then 2 is already isolated, so that we have not to further derivative 0 is equal to 0. Now arrange it. After solving this question, before we have to know about this n c1 is equal to n times derivatives, n c2 means n times n minus 1 by 2 times derivatives. Now write this 1 plus now it means the solution is, the question is solved. nc1 is value is n times dot 2x dot yn plus 1 plus n minus 1 by 2 dot 2 yn plus 2x minus 1 n plus 1 plus n 2 yn. After arranging it, this values will be solved. This question will be solved easily. Here is the answer. 1 plus x square n plus 2nx plus 2x minus yn plus n square yn is equal to 0. After solving this proved. Thank you. Do a screenshot and paste it.